Welcome everyone to our AI on AI podcast. Today we're diving deep into prompting techniques for software engineering tasks, and we've got an incredible panel ready to unpack everything from technical nuances to real-world business implications.
Thanks for having us. What's fascinating here is how even minor tweaks in prompt engineering, like the structure or token count, can drastically shift an LLM's performance in tasks such as bug fixing or code summarization.
Absolutely. And the experimental analysis we're looking at evaluated 14 distinct prompting techniques across 10 different SE tasks, which gives us a comprehensive look at how techniques like ESKNN or self-refine push the envelope in code generation and debugging scenarios.
Right. And from a technical standpoint, the study's deep dive into linguistic metrics, like lexical diversity and Flesch-Kincaid readability, really shows that it's not just about prompt length, but the quality and structure of language itself, which can be a real game changer in complex reasoning tasks.
I see what you mean. And speaking of real-world impact, I'd add that companies deploying these techniques have seen significant improvements. Imagine a scenario where a retail giant uses an optimized prompting technique to reduce bug resolution time, cutting costs by nearly 15%.
That's a powerful insight. And on the technical side, the use of contrastive explanations to analyze why one prompting strategy outperforms another is not just academic. It pinpoints which aspects, like structured guidance and in-context examples, are critical for high-quality outputs.
Wow, that's interesting. So it's a blend of structured linguistic features and the right examples that lights the way forward. Can you elaborate on how the study dissects, say, the ESKNN technique?
Sure, ESKNN, which selects exemplars based on cosine similarity in vector embeddings, essentially enriches the prompt with semantically similar examples. This method consistently outperforms simpler prompts because it effectively guides the model through contextual awareness.
And technically, the approach leverages multilingual embedding models that cater to both natural language and source code, a factor that enhances performance across various tasks like clone detection and exception type prediction with impressive z-scores.
From the strategic business view, what's compelling here is that while ESKNN is powerful, it comes at a higher token cost. This means that in budget-sensitive deployments, businesses might weigh its benefits against resource costs. In other words, balancing performance gains with financial efficiency.
Exactly. And that's where techniques like role prompting come in as a token-efficient alternative. It assigns specific personas to the prompt, which occasionally results in lighter models performing better with fewer tokens, making it a practical choice for operational costs.
I'd also mention that the study highlights a surprising twist. For some models like OpenAI's O3 Mini, the best technique turned out to be different from the larger models, emphasizing that prompt model alignment isn't one size fits all.
And that observation really drives home the need for adaptive prompting strategies, as tweaking the approach based on model-specific behavior can actually save not only tokens, but also inference time, which is critical in enterprise deployments.
On that note, the paper's analysis of resource costs is eye-opening. When you break down token count and response time, you see that tasks such as code generation have massive token savings potential, whereas tasks like code QA do differently, hinting at the inherent complexity in various SE tasks.
It sounds like a real balancing act between efficiency and effectiveness. Could you provide an example of how a real-world business applied these insights?
Sure, picture a software development company that integrated ESKNN for bug fixing tasks. While it increased token usage by adding extra exemplars, the dramatic reduction in debugging time and fewer errors ultimately boosted their product reliability and slashed support costs.
Building on that, another business case is from a tech startup that experimented with self-generated in-context learning to automatically generate few-shot examples. This streamlined their workflow, reducing the iterative trial and error phase in prompt engineering by nearly 20%, which is huge from a productivity standpoint.
And let's not forget the role of iterative refinement methods, like self-refine, which allow the model to self-evaluate and correct outputs. In high-stakes environments where code correctness is key, this iterative loop offers an edge in maintaining quality while adapting to complex requirements.
I'd also add that the contrastive explanations offered in the study provide us with interpretability, a feature that's essential in debugging advanced prompts. When the model is asked, "Why did your output perform better here than there?" it becomes possible to adjust the prompt further, ensuring continuous improvement.
That's an excellent point. Transparency in model behavior is critical, and leveraging contrastive explanations uncovers factors like ambiguity reduction and robustness. These categorizations not only inform improvements in prompt design, but also serve as guidelines for future research.
Fascinating. This reminds me of the famous quote by Einstein: "Everything should be made as simple as possible, but not simpler." And that seems to perfectly encapsulate the balance needed in prompt engineering.
Exactly. And in the business world, the rule of thumb is the 80-20 rule. 80% of the gains can often come from 20% of the effort in optimizing these linguistic and structural aspects of prompts.
Yet, here's an unexpected twist that challenges conventional thinking. While many focus on reducing token costs, sometimes a less token-efficient prompt might offer significant performance improvements. So it's about finding that sweet spot where the model's output quality justifies the additional resource consumption.
I agree. This contrarian view highlights that efficiency shouldn't come at the expense of output quality. For example, in mission-critical systems where reliability is non-negotiable, investing in a more resource-intensive technique could be the smarter long-term strategic decision.
Speaking of strategy, one emerging opportunity is to develop automated prompt optimization tools. Such tools could dynamically adjust the prompt based on task requirements and model behavior, effectively automating the process of selecting the optimal prompting technique.
And that's where R&D can really break new ground. By integrating adaptive mechanisms that consider factors like lexical diversity and readability metrics, these tools can offer real-time feedback, much like a prompt compactor that ensures maximum efficiency without sacrificing clarity.
That sounds like a real game changer for both technology and business, seamlessly aligning R&D efforts with operational efficiency. How do you see this evolving in the near future?
I envision a future where prompt engineering is as automated and fine-tuned as any other aspect of software development. Companies could have dashboards that monitor prompt performance in real time, analogous to how businesses track key performance indicators.
And from the business lens, this evolution means more predictable performance outcomes and reduced costs. Imagine an enterprise deploying LLMs that dynamically adjust prompts based on resource constraints, resulting in consistent quality while keeping operational expenses in check.
Technically, this will likely involve advanced simulation environments for prompt testing, where multiple techniques are pitted against each other until the optimal balance emerges. Think of it as an A/B testing framework for prompt engineering applied at scale.
Yes, and as more datasets and benchmarks become available, as seen in the study with over 2,000 prompts tested, the community can converge on best practices that not only boost performance, but also standardize prompt design across different SE tasks.
I'd also emphasize that while the current work lays a strong foundation, future research will need to extend these findings to additional dimensions, like prompt embedding spaces and multimodal interactions, further enriching the toolkit for prompt engineers.
Absolutely. And it's fascinating how these strategies aren't confined to academia. They're starting to have a palpable impact in the software industry, from automated code review systems to intelligent debugging assistants.
Indeed, one project I recall had a business reduce cycle times significantly by integrating an LLM-based code assistant that leveraged several of these prompting techniques for commit message generation and bug repair. The results were nothing short of transformative.
And another example is a firm that used analogical prompting to simplify complex code architecture explanations. By drawing parallels with everyday scenarios, they not only improve developer comprehension, but also enhance cross-team communication, a vital aspect for enterprise scalability.
It's these real-world applications that drive home the point. The insights from prompt engineering research are making a tangible difference in business operations, fueling both innovation and efficiency in software engineering practices.
I think it's crucial that we maintain an interdisciplinary dialogue here. The convergence of deep technical expertise and strategic business insights creates a fertile ground for innovation, where the value of a well-constructed prompt is measured not just in performance metrics, but also in real economic impact.
And by continuously refining these approaches, we can move closer to a future where LLMs are not only smarter, but also more predictable in their behavior, ensuring that the technology scales reliably with business needs.
Fantastic perspectives, everyone. It's clear that the nuances of prompt engineering, from linguistic characteristics to computational resource management, are reshaping how we approach software engineering tasks.
Well said. Balancing technical depth with strategic goals is the key, and it's an exciting time as we see these ideas transition from research papers into practical, revenue-driving solutions.
I'd add that the push toward adaptive, automated prompt optimization will not only streamline the development process, but also democratize access to advanced AI capabilities, even for smaller businesses with limited budgets.
And let me throw in one more thought. While many focus on maximizing efficiency, sometimes the real breakthrough lies in understanding the why behind prompt performance. That's where contrastive explanation methods come in, providing transparency that ultimately builds trust with end users.
That's a critical point. Trust and interpretability are as important as raw performance, especially in regulated industries where explainability can be the differentiator between adoption and rejection.
In conclusion, our conversation today paints a promising picture. By combining technical innovation, empirical research, and strategic application, the future of prompt engineering holds immense potential for transforming both how we build software and how businesses operate.
Thank you all for this enlightening discussion. It's been a deep dive full of technical insights, strategic business cases, and a few surprising twists along the way. I'm sure our listeners now have a richer understanding of how crucial and multifaceted prompt engineering has become.
Thank you for the opportunity. We're excited to see where this field goes next and how these techniques will continue to evolve.
It's been a pleasure discussing these breakthroughs, and I look forward to future innovations that push these boundaries even further.
Likewise, thanks everyone. This is a conversation that will surely keep evolving as we blend research, business needs, and technical prowess.
Thanks for listening, and remember, sometimes the simplest changes in prompt design can lead to the most remarkable shifts in performance.
Until next time, keep pushing the envelope and stay curious about how these insights will shape our digital future.
Welcome back to part 2 of our podcast. Now that we've explored the overall impact of prompt engineering techniques, let's dive into the nitty-gritty implementation details and how these methodologies translate into real-world applications.
Sure, let's start with the ESKNN technique. Technically, it involves converting data samples into vector embeddings using a pre-trained multilingual code-optimized model, and then computing cosine similarity to select the top K in-context examples for each query.
Right. And the beauty here is that this method directly influences performance metrics like code generation accuracy and bug fixing. The extra context provided by relevant exemplars often leads to higher Z-scores, albeit with a trade-off in token consumption.
Technically speaking, one must carefully balance the number of exemplars added. If you include too many, you inflate token counts and delay inference time. But too few examples might reduce contextual clarity, so the implementation requires tuning based on the specific task.
And from a business perspective, this tuning process is critical. Imagine integrating a dynamic dashboard that monitors token usage versus performance gain in real time, enabling enterprises to optimize operational costs while ensuring output quality.
On the technical side, another fascinating aspect is contrastive explanation. The paper details how LLMs are prompted to explain why one prompt variant achieves higher performance than another, and this is achieved by comparing structured outputs from the best and worst techniques.
Exactly. And that process involves feeding in controlled prompt variations, then analyzing linguistic metrics like lexical diversity, Flesch-Kincaid, grade level, and token count to quantitatively correlate these features with performance improvements in tasks like code summarization.
In practice, an implementation might involve a pipeline where prompts are first validated using automated grammar and consistency checks before being passed to the model, ensuring that variations only affect semantical structure without introducing noise.
I'd add that the extraction of these linguistic features isn't trivial. It requires leveraging tools to compute metrics such as the moving average type token ratio, MAT, and readability indices, which then feed into a Spearman correlation analysis to determine which features are most predictive of performance.
This is where businesses can really benefit. The ability to quantify and monitor these metrics can help decision makers weigh the resource costs against performance gains. For example, one company might accept higher token consumption if it statistically leads to fewer bugs and faster patch resolutions in production systems.
And let's not forget, techniques like self-refine and self-generated in-context learning offer iterative improvement. These methods allow the model to generate an initial response, then reevaluate and improve it, which is particularly useful in scenarios like generating documentation or commit messages where precision is paramount.
That's a key insight. Iterative refinement not only boosts quality, but also offers a built-in feedback loop, similar to continuous integration in software development, where each pass through the model serves as a code review step.
Precisely. And applying these techniques in production often involves setting up asynchronous processing pipelines where initial responses are generated quickly, then refined in subsequent iterations, balancing speed with accuracy.
On the technical implementation side, these pipelines might use parallel processing, running multiple reasoning threads concurrently, such as with the tree of thought method, where multiple solution paths are developed and then a meta prompt selects the most consistent outcome.
And this is where advanced hardware infrastructure plays a role. Enterprise deployments may leverage GPU clusters to handle the heavy computational overhead, especially when the LLM is processing long prompts with extensive exemplar data.
From the business angle, investing in such infrastructure or leveraging cloud-based APIs that optimize token efficiency can make a huge difference in cost projections, impacting the bottom line in large-scale software operations.
I also want to highlight the unexpected insight from the paper. On lighter models like the OpenAI O3 Mini, simpler token-efficient prompts like role prompting provided the best results, showing that sometimes less is more and that model-specific adaptations are vital.
That observation underlines an essential strategic point. When rolling out LLM solutions, businesses need to choose prompt engineering techniques that are tailored not only to the task, but also to the underlying model's architecture and limitations.
In terms of real-world implementation, companies can integrate automated prompt optimization tools that analyze live performance metrics, dynamically refine prompt templates, and even conduct A/B tests to continuously improve the solution's efficiency.
Such tools would likely use machine learning themselves, perhaps a meta model that predicts the optimal prompt configuration based on task complexity, current token usage, and expected inference latency, essentially automating the prompt tuning process.
And that's precisely where business benefits translate into tangible outcomes. Faster deployment cycles, lower operational costs, and eventually a competitive edge by leveraging these adaptive techniques in areas like customer support chatbots or automated code assistance.
I think it's also worth mentioning that integrating these methods requires rigorous testing and validation, much like traditional software quality assurance. Ensuring that each prompt variation adheres to expected formats is key to maintaining system robustness over time.
To sum up for our business leaders, the crux of the matter is this. By embracing these sophisticated prompt engineering techniques, companies can not only automate software tasks more effectively, but also optimize performance versus cost, a balance that drives strategic advantage.
Exactly. An investment in well-engineered prompt strategies can reduce debugging time, improve code quality, and even enhance user experience by generating more accurate documentation and support responses.
And for our technical audiences, the devil is in the details. From using cosine similarity and exemplar selection to implementing iterative self-refinement mechanisms and setting up meta models for dynamic prompt optimization, there's plenty of rich, actionable insights to be explored.
The implementation isn't without challenges, though. The trade-offs between token consumption, response time, and output quality require careful empirical analysis, much like the studies in the paper that use z-score normalization to compare disparate metrics on an even footing.
In practice, businesses that monitor these metrics in real time can adjust their prompt strategies on the fly, much like adaptive control systems in engineering, ensuring that the AI behaves optimally under varying loads and conditions.
Ultimately, this deep dive into implementation underscores that prompt engineering is not a static art. It's an evolving science that combines linguistic analysis, algorithmic finesse, and continuous feedback loops to deliver strategic value in a cost-efficient manner.
Thank you all for this technical deep dive. These insights not only break down the mechanics behind advanced prompt techniques, but also provide a roadmap for practical business applications that can revolutionize software operations.
It's been a pleasure discussing this, and the possibilities are endless when we blend rigorous technical methods with forward-thinking business strategies.
I couldn't agree more. This conversation illustrates that by understanding the fine details of implementation, we can drive both innovation and measurable economic impact.
Absolutely. These techniques are the bridge between pure research and real-world application, ensuring that businesses can scale their operations with intelligent, adaptive AI solutions.
And as companies continue to evolve their digital strategies, I foresee that prompt engineering will become a cornerstone of AI integration, much like agile methodologies have changed software development.
Let's keep pushing the boundaries. There's plenty more to explore at the intersection of AI prompt techniques and business-driven outcomes, and I'm excited to see what comes next.
That wraps up our Part 2 deep dive. Thanks to all our experts, and thanks to our listeners for joining us on this technical journey. Stay tuned as we continue exploring the ever-evolving landscape of AI innovations. As we head into our final segment, let's take a moment to summarize and wrap up this deep dive into prompt engineering and its real-world impact.
To recap, our discussion explored how techniques like ESKNN enhance contextual understanding by using vector embeddings and cosine similarity, driving noticeable improvements in tasks like code generation and bug fixing, despite the inherent trade-offs in token usage.
And on the flip side, our deep dive into contrastive explanation methods revealed how comparing prompt variations not only refines technical precision, but also builds a bridge to measurable business outcomes, elevating both quality and efficiency.
We delved into key innovations like iterative self-refinement, parallel processing with tree of thought, and dynamic meta-models for prompt tuning, each of which underscores the intricate balancing act between computational resource management and output quality.
From a strategic standpoint, these adaptations open up new avenues for businesses to monitor and control operational costs in real time, much like agile methodologies in software development, ultimately securing a competitive edge in dynamic markets.
An unexpected takeaway was the performance of simpler, token-efficient methods such as role prompting on lighter models, reminding us that sometimes less is more when it comes to effective prompt engineering.
In essence, our conversation highlights how prompt engineering is a multifaceted art, merging linguistic insights, rigorous technical strategies, and business objectives into a cohesive framework for AI-powered solutions.
Yes, by integrating deep technical metrics with adaptive strategies, organizations can streamline tasks like code summarization and defect detection, driving both innovation and operational efficiency.
And by continually monitoring performance factors such as token counts and inference latency, technical teams can ensure that the system evolves in tandem with emerging market demands.
Ultimately, the future of software engineering lies in this synergistic blend of research-backed prompt strategies that are both cost-efficient and scalable, ensuring robust deployments in real-world settings.
These insights empower businesses to make informed decisions, optimize resource allocations, and maintain agility, a strategy that historically, as the 80-20 rule reminds us, focuses on driving the greatest impact with the most effective techniques.
As we close today's session, it's clear that adaptive, context-aware prompt engineering isn't just about refining code. It's about crafting an environment where AI solutions are both precise and pragmatically tuned to meet business challenges.
Thank you all for this engaging and insightful conversation. Your expertise has truly illuminated how technical innovation and strategic business planning can converge to shape the future of AI in software engineering. Until next time, keep pushing the boundaries of what's possible.